Okay, so adding, subtracting, and multiplying polynomials. You will master polynomial functions. Okay, so here's some examples of polynomials, and let's just take a look at this. So if we notice here, up top, all of these, they don't have any like square roots or fractions, and all of our powers here are whole numbers. Okay, we don't have any fractional exponents, so we don't have like an x to the 1/2. Okay, that's bad. So polynomials are just a bunch of monomials put together, added together, okay? And so you have to have positive exponents, no fractional exponents, and no negative exponents, okay? Most of this should be review, hopefully, but the polynomial is the sum and difference of many monomials. The highest exponent of the polynomial is called the degree. And standard form is when the degrees go from greatest to least. So here are some examples of polynomials. And these are all in standard form. And we can look at these. So the highest degree here is a 1, right? So this would be a first degree polynomial. Okay, the highest degree here is a 2, so this would be a second degree, which is also called quadratic. Okay, this is also a 2, so that's again a second degree and quadratic. And this is a 3, so that's a third degree. We can also classify these by numbers of terms. So since this has 2 terms, this would be a binomial. This one also, so that's also a binomial. This has 3 terms, so it's a trinomial. And then this one has 4 terms, and anything bigger than 3 we just call a polynomial. Okay, monomial just means 1 term, so like we could say like 3x squared. That would be a monomial. Binomial has 2, trinomial has 3, polynomial has more than that. Okay. Sorry, I don't know how to get all the my writing to stay. Use standard form. So make sure that you always, whenever you write these as answers, they always have to be written in standard form. So we just classified these by numbers. We didn't do it in the last video. We just barely did it. But mono means 1, bi means 2, tri means 3, poly means more than 3. We can also classify them by degrees, which I was already kind of doing. But if it was a 0 degree, it'd be a constant. So that could just be a number. That is just a number. First degree is linear, which that's just when you have an x. Second degree is quadratic, so that's an x squared. Third degree is cubic, so that's x cubed. Fourth degree is quartic, and fifth degree is quintic. And we're not going to go past 5. Okay. Don't forget. Okay, so adding and subtracting polynomials, pretty straightforward. We're just going to combine like terms. So b squared and 8b squared is, you could go through the steps of this if you want. So since they're adding, I just dropped the parentheses. And then I'm going to put the terms right next to each other. Now, you don't have to go through all these steps. If you want to, we could just go like this. Well, b squared plus 8b squared is 9b squared. 5b plus negative 2b is 3b. And then 11 minus 7 is 18. Sweet. Okay, and you're going to get the same thing here. Okay, this one, so the parentheses drop, and then we can combine like terms, and so we end up getting 5k cubed. Those k squareds cancel, so negative k squared plus k squared is gone. And then negative 4k, 7 plus 2 is 9. Okay, subtraction. Now when you have subtraction, I'm actually just going to write this out. When you have subtraction, you have to distribute the negative sign. So that becomes negative 9 minus 3w squared minus 7w. And then we can combine like terms. So those ones cancel. 2w minus 7w is negative 5w. And negative 6 minus 9 is negative 15. Okay. And if I click through this, addition, subtraction. You distribute it. There you go. Drop the parentheses and then combine like terms. SpongeBob says, what are 2 steps of adding and subtracting polynomials? You distribute and get rid of the parentheses, then combine like terms by adding or subtracting. Now, if SpongeBob can add and subtract polynomials, you can add and subtract polynomials. This one, same thing, distribute that negative sign. So you get negative y plus 3y cubed minus 4y squared. Combine like terms, and we end up getting, sorry, I rewrote this a bunch of times. I wish I would have just like combined them. But when you combine that, you get 4y cubed minus 7y squared minus y minus 2. Cool. You forgot to change the sign when subtracting a polynomial, but that's none of my business. So a lot of times people get these wrong just because they forget to change the signs when they're subtracting. So always distribute that subtraction sign. Okay? Multiplying polynomials and closure. Today we multiply polynomials. Oh, I wish I could be like as intense as he looks, but that's embarrassing. Okay, let's do this one. I'm going to do it by hand, and then we can click through my work. So here, we can distribute these. So 5w times negative 7w is negative 35w squared. 5w times 3 is 15w. Negative 2w times 13 is negative 26w. And negative 2w minus 9w squared is 18w cubed. Combine like terms, put it in standard form, so that's 18w cubed minus 35w squared minus 11w. Those two combine to be negative 11. Let's click through, make sure we got that right. Perfect. Okay, let's do this one. So again, we're going to distribute that negative sign. Let's see, I want to move this down a little bit. Or distribute these. And this negative sign needs to distribute also. So negative 2r times r cubed is negative 2r to the 4th. Negative 2r times negative 6r squared is positive 12r cubed. Negative 2r plus 6 is negative 12r plus 4r cubed. And then that's negative 5r to the 4th minus 10r. Okay. Combine like terms, so those two combine to be negative 7r to the 4th. Those two combine to be 16r cubed, and those combine to be negative 22r. Sweet. Let's make sure we got the same thing. Yep. Okay, let's go through this one. This one is a little trickier, not too bad, but we have parentheses inside of parentheses, so we have to work inside of these first. So let's do that piece first. So that's going to be negative 15ab plus 10b squared, then 2a squared, and then everything else is just following here. Okay, if you remember PEMDAS, that's parentheses and then exponents. Multiplication and division just go left to right, and addition and subtraction go left to right. Please excuse my dear Aunt Sally. I've heard some other weird ones, but whatever makes you remember it, awesome, do it. So then here we can distribute this in there now. So that's going to be 8a squared b minus 60ab plus 40b cubed plus 29ab squared. And then we don't have anything to combine from there. So, is that right? Yep, there's nothing that we can combine from there. If I did it right, let's check. Okay, so we distributed that part and got 15ab and positive 10b squared. Then distributed that in, and we get 8a squared b minus 60ab squared plus 40b cubed plus 29ab squared, which is what I ended up with. But what did I try and combine? Oh, duh. Okay, I made a mistake. So when I was doing it before, it was right here. This, I think I just had 60b squared. I'd have to go back and look. I don't remember. But then these two can combine. Okay. Blah, blah, blah. There you go. Okay. We make mistakes. That's why you always kind of double check yourself. Okay. It's literally the first video of the year, and I'm already like, oh, mistakes make you a better person. Blah, blah, blah. Welcome to Miss Gagan's class. Okay. So multiplying a binomial by a trinomial. Math teacher, after I explained to him/her how I used a different method to get the same answer. Amazing. Every word you just said was wrong. We've all had teachers like that, right? I don't care how you do this. So you could use distribution or you could use the box method. Whatever you do, as long as you get to the same answer, it's fine. Okay, I am going to use the box method. So if we're multiplying a binomial by a trinomial, so that's a 2 by 3. And then we're just finding areas. So this is a lot like what you do in biology when you're like finding dominant and recessive genes. You can just like multiply them. So x times x squared is x cubed. X times 3x is 3x squared. X times negative 6 is negative 6x. 4 times x squared is 4x squared. 12x, negative 24. And then just combine like terms. Pretty easy. You've done this before. I'll do one more. So again, just set up the box and then multiply. So 3a times 5a squared is 15a cubed. 2a times 3a is 6a squared. Negative 6 times 3a is negative 18a. 5a squared times 1 is 5a. Then 2a and negative 6. Combine like terms and we end up getting 15a cubed plus 11a squared minus 16a minus 6. Cool? Okay, let's do this one. So if this is to the third power, that means that I have 3 of those. Okay, and I'm going to do this by hand. So I'm going to multiply these two together first. And let's just use distribution here. So 3x times 3x is 9x squared. 3x times negative 4 is negative 12x. Again, negative 12x. And then negative 4 times negative 4 is 16. So that's 9x squared minus 24x plus 16. But we still need to multiply this one. So we still have that 3x minus 4. Okay, and then let's use a box here. Oh, wait. So we have 3x minus 4, 9x squared, minus 24x plus 16. 3x times 9x squared is 27x cubed. 3x times 24 is 72x. 3x times 16 is 48x. 9x squared times negative 4 is negative 36x squared. Negative 4 times 24, that's positive 96x. Negative 4 times 16 is negative 64. So then that's 27x cubed. Combine those two, so negative 36 minus 72. I'm using my calculator, so I don't make a mistake. 96 plus 48 is 144. And then minus 64. So that was like a double multiplication problem, right? Okay, let's double check and make sure we did it right. Multiplied those two, got that, multiplied that one, and get that. Okay, so if you see that like third or fourth or whatever, that just means you have to do it that many times. So if we do it to the fourth power, that means we have 4 of those. I'm going to click through this pretty fast, but then we can multiply the first two together, and you end up getting 4x squared minus 12x plus 9. And so that's going to equal the first two parentheses and the second two. And then we can use a 3 by 3 box to multiply all of that. And we end up getting 16x to the 4th minus 96x cubed plus 216x squared minus 216x plus 81. I know I went through that fast. I'm just trying to make this video not long. But if you want to pause this and try it and make sure you get that same answer. Okay. Wow, look at all that hard work. I'm impressed. Yep, thank you. Closure. Okay, this is the last thing. So we have all these different definitions of closure. You can think of closure as like you just broke up with your boyfriend and you need to talk so that you can have that closure. Or it's like closing the door or whatever. But in math, it's the property that a number system or set has when it's mathematically closed under an operation. And what that means is that if you apply an operation to a set of numbers, you're going to get a number in that same exact set. Okay, that might have just sounded like a different language to you. So let's do some examples. So are the integers closed under addition? Well, what the heck is an integer? An integer is just a positive or negative number, whole number. So -4, -3, -2, 1, 0, 1, 2, 3, 4, 5, 6, 7, 999, like 407, those are all integers. Okay, we want to know if there's closed under addition. Another way of asking that is saying, if we add two integers together, will we always get another integer? So if I do 1 plus 2 is 3, that's an integer. 314 plus 913 is 1,227, that's an integer. -42 plus 87 equals 45, that is an integer. I could do two negatives, I still get an integer. So yes, those are closed under addition. So you would say yes, the integers are closed under addition. What about subtraction? If I had to guess, I'd say yes, but if we subtract two integers, will we always get another integer? Let's just check it. 1 minus 2, -1, yep. 314 minus 913, yep. Two negatives, yep. All of them work. So, yep. Will you always get an integer? Yes. So, are the integers closed under subtraction? Yes. And you could do this with like odd numbers. You could do it with fractions. You could do it with whatever. Okay. Let's try multiplication. So, if we multiply two integers together, will we always get another one? Well, I did a bunch of them, and I'm getting big integers or really small integers. But yes, Cookie Monster says, yep, they always work. Okay, what about division? So if I divide, will I always get another integer? Well, if I do 1 divided by 2, I get 0.5, which is 1/2, which is not a whole number, so no, we will not get an integer. Cool Monkey says, I don't even know what kind of monkey that is. Like, does anyone know? Because he is pretty awesome. Anyways, that's it. Thanks for watching. Remember to take the quiz. Bye.